Traditionally, organizations were focused on gathering insights from structured enterprise data generated through internal systems. These insights were limited in the opportunities that they offered. But with the big data phenomenon, a new world of insights and analytic opportunities has opened up for businesses, and the path to it is through the analysis of the exponentially growing volumes of unstructured and semi-structured data generated from a variety of new sources. To get the most out of big data, businesses will need to complement the traditional business intelligence and data warehousing tools with new technologies that support and process unstructured and semi-structured data in real time. But first, they will need to integrate big data with enterprise data and into business processes. In this video, you will learn how big data can be made a part of the business process so that it can be used by decision makers to gain competitive advantage in the markets they serve. You will learn about the stages in data analysis, the process of integrating various data sources, and the key factors that characterize big data workflows. Let us first discuss what an organization would need to do to be able to combine the traditional decision-making process with big data analytics. Before a business starts with an analytical application development for big data, it must first evaluate and analyze the existing systems to reveal the business requirements for big data analytics. Then, it must identify the type of data required. Data identification is a prelude to developing new analytical applications. For instance, a business may need to move large amounts of Twitter and RFID feeds. Once that's in place, the business would have to identify the sources of data that are relevant to its processes, finally leading to analysis and integration of results to business processes. Let's understand this with an example. We'll look at how an approach to a patient treatment process could be improved using big data. This flowchart shows the process followed in the traditional treatment approach. Notice that most data used during treatment remains localized to a healthcare network. Physicians have little time to go outside the network to find the latest information or practices. Their analysis is confined to the traditional medical record and patient data, such as test result. As a result, patient care options are limited. With big data, the network can now access a wealth of new information from diverse sources, such as medical devices, clinical trials, leading to exploration of new actionable insights for managing a disease and patient care. This, in turn, can improve the effectiveness of diagnosing and managing healthcare in the future. Notice that in both cases, the processes are relatively unchanged. However, the underlying technologies now include the applications that need to be altered to accommodate the impact of big data, such as the volume of data, variety of data sources, and the speed or velocity required to process that data. At this point, it is good to note that with big data, in the beginning, it is difficult to specify what insights it will throw up, but as it goes through the different stages of analysis, patterns and results begin to emerge. In the healthcare example, we saw that the existing workflow needed to be modified to accommodate big data-related tasks and technologies leading into a big data workflow. Now, what are workflows, you may ask? Workflows are task-oriented and require more specific data than processes. Processes, in turn, are composed of one or more workflows. In the healthcare example, one elementary workflow is the process of drawing blood. Once that's done, you need to conduct an analysis. Now, in the standard data workflow, the blood is drawn and the chemical tests recommended by the practitioner are performed. Here, if you supplied big data sources for biomarkers and mutations, the workflow would fail, because it is unlikely that this workflow understands the testing required for identifying specific biomarkers or genetic mutations. The workflow, therefore, will need to be modified or rewritten to support big data. Thus, to incorporate big data workflows in your business, first, identify the big data sources you need to use for your business. Next, map the big data types to the workflow data types. Also, ensure that you have the processing speed and storage needed to support the workflow. Then select the data store best suited to the data types. Finally, modify the existing workflow to accommodate big data, or create a new big data workflow. That was one case study of how big data can be integrated into an existing scenario. Let's now understand the concepts behind such big data implementation. The stages involved in developing an analytical application that would be needed to integrate big data into your businesses are 1. The discovery stage, 2. The exploratory stage, 3. The codifying stage, and 4. The integration and incorporation stage. Let's look at these stages in detail. The discovery stage is the basic analytics stage. This is the requirement gathering phase and is essential for any type of analytics. It is the groundwork that is done to identify the problem, feasibility of the requirement, and a high-level description of the solution. At this stage, the user is yet to perceive if the data is valuable. Basic analytics may include the use of scorecards, dashboards, simple visualizations, or simple statistics. The exploratory stage, also known as pilot stage, involves searching for patterns in data. These patterns, in turn, may give an insight into new and unexpected relationships and correlations among elements. The processes that businesses, therefore, follow at this stage involve 1. Collecting sample data and select analytical tools, such as the extract, transform, and load (ETL) technology. 2. Perform data quality checks and transform data as needed. 3. Develop analytics and models of big data. 4. Develop visualization alternatives. And 5. Validate results and finalize a model. The search for data patterns often leads to the narrowing down of huge data volumes. Once the data pattern has been identified at the exploratory stage, it needs to be incorporated into business processes. How can you do this? Just codify it. So, in the codifying stage, also known as the development or model development stage, organizations should be able to make the connection between big data analytics and existing systems. For example, a retailer who monitors social media identifies a lot of chatter about an upcoming college sports event near one of its stores. With this new information and insight, the retailer can set up a process to take quick action and stock the local store with suitable merchandise that can boost sales. Thus, the codifying stage helps in verifying the results of the analytical application, and this includes building of statistical models or machine learning models, such as the decision tree, for instance. These models might then be improved iteratively. In other words, this is the process of teaching the business rules to the model. In the above retail example, if the business were to achieve this kind of a leap from insight to implementation of new product selection, it will need to ensure that it is a repeatable process and for which big data analysis must be integrated with the business's operational data. But how is this done? The last stage in big data analysis is the integration and incorporation stage, which allows you to integrate and incorporate the results into your business and real-time business actions. In this stage, data management becomes critical as big data platforms demand speed and scalability to manage structured and unstructured data. Businesses will need to prioritize data quality with an emphasis on accuracy and completeness of data to ensure that quality and trusted data is delivered to organizations at the right time and in the right context. Other than this, you would also need to implement some data governance rules. Big data governance is an important part of the analytics equation. Underneath business analytics, enhancements will need to be made to existing governance solutions to ensure the veracity coming from the new data sources, especially as it is being combined with existing, trusted data stored in a warehouse. Data security and privacy solutions also need to be enhanced to support managing, governing big data stored within new technologies. Hence, with big data, data integration technologies will need a common platform that supports quality and profiling of both enterprise data and big data. Also, this information must be delivered in a controlled and consistent way across the enterprise, and must be understood at all levels of the organization, regardless of specific requirements of systems and applications. To integrate data across mixed application environment, data will need to be transferred from one data environment source to another data environment, target, in acceptable formats. You can use the data integration and transformation technologies to do this. These technologies help you extract data from external sources, transform that data into an acceptable format, and load or push that data into the required area. Finally, with big data, before applying it to operational processes, businesses will also have to check for the following characteristics of big data. Validity. Is the data correct and accurate for the intended usage? Veracity. Are the results meaningful for the given problem space? Volatility. How long do you need to store this data? Now that we have discussed the various stages in big data analysis, let's see if you can answer this question based on what you've learned so far. If you selected collecting sample data and selecting analytical tool and using BI tools for reporting, you are right. The exploratory stage of developing an analytical application includes 1. Collecting sample data and selecting analytical tools, such as the extract, transform, and load (ETL) technology. 2. Performing data quality checks and transforming data as needed. 3. Developing analytics and models of big data. 4. Developing visualization alternatives. And 5. Validating results and finalizing a model. Let's do a quick recap of what you've learned in this session. The various stages of developing an analytical application include the exploratory, codifying, and integration and incorporation stages. The discovery stage, the basic analytics stage, includes the use of scorecards, dashboards, simple visualizations, or simple statistics. The exploratory stage involves searching for patterns in data. The codifying stage involves limited implementation in business processes to verify the results of the analytical application. The integration and incorporation stage allows you to integrate and incorporate the results into your business and real-time business actions.